Hi, my name is Per, and I am an astrophysicist. So whenever I meet new people and I tell them that I study astrophysics, there's usually first a moment of silence, and then heaps of questions like, what are black holes? Is the universe infinite? And is there really life out there? And that's one of the things that I absolutely love about doing astrophysics, that it's something that so many people are so curious about. But as we keep talking, we inevitably get to the point where they ask me, so what is it that you actually do? And is astrophysics really all that useful? And that's what I'd like to talk about here now with my presentation called How Astrophysics Can Make Your Milk Cheaper. So to answer that question, we start here. This is the Large Hadron Collider outside of Geneva, Switzerland. And the Large Hadron Collider is a particle accelerator. They take the tiniest building blocks of matter and accelerate them to incredible speeds. They then smash them together and then look at the shrapnel of this collision to figure out how things work at these particle levels. Another instrument that we use to answer the same kind of questions is this one. This is the Hubble Space Telescope, and it's one of many telescopes we have orbiting the planet many hundreds of kilometers above ground. And now you may be wondering, so what could we possibly learn from a measly telescope many hundreds of kilometers above ground that we can't learn from a 27-kilometer long particle accelerator that is right here on Earth? Why would you want to go to space when you can just do it right here on the ground? Well, the thing is that the Large Hadron Collider is a huge particle accelerator, the largest in the world, but it is just that, here on Earth, our planet, one of 8 in the solar system, and our sun, just one of billions of stars in the galaxy, and our galaxy being just one of billions of galaxies in the universe. Now, the physics that govern how things work at these incredible scales is the exact same physics that govern how things happen down here on the ground. And just by doing what it naturally does, the universe puts on experiments on a much longer and much grander scale than we could ever hope to achieve down here on the ground. So by looking at the physics of the most extreme in the universe, we can actually learn about how physics works right here on Earth. There's a long history of doing just that, from understanding the laws of gravity by looking at the motions of the planets in the solar system, to understanding how atoms work by looking at fusion happening in stars, including our own sun. So to put all of this in other words, the universe conducts experiments much, much grander, much more incredible than we could ever do here on the planet, and all we have to do to tap into this source of knowledge is simply to look up into the universe. Now, I have a movie that shows very shortly how good we actually are at doing that, looking into the universe. And it starts with this image of a supernova taken by the Hubble Space Telescope, and as we zoom out, these images are laid on to wider field images taken with other telescopes, and as we zoom out, and we zoom out, and we zoom out, and we zoom out just a little more, we finally get to something that looks a little more familiar. So, I've shown you some very pretty pictures, and I've explained to you that astrophysics can explain how the universe fundamentally works, but you might be wondering, and especially if you're an economist, and I'm not going to hold that against anyone here, if you're an economist, you might be thinking, so this is all very good, but what is the economic gain by doing astrophysics? It's incredibly expensive to put these telescopes into space. Isn't it really, really right that we should get some economic return on this investment? And to this question, I have 2 answers. The first is that there is, in fact, some tangible discoveries that we get from doing astrophysics, and one of them that I think you may have heard of is called Wi-Fi. That was what we just saw before. So the way the story goes is that a bunch of astrophysicists at the Parkes radio telescope, they used this huge radio telescope to hunt for exploding black holes. And to do this, they had to process huge amounts of radio data very quickly, very efficiently. And to do that, they came up with the mathematical algorithms that today are at the heart of every single Wi-Fi system in the world, from your phones to your tablets and your laptops. So unfortunately, the hunt for these exploding black holes failed, but thanks to these clever Australian astrophysicists, we never have to mess around with cables when we're on the go and just have to connect to the internet. So the answer that I just gave you is definitely true. There are some tangible benefits some tangible direct benefits from doing astrophysics, but that's not really why I get up in the morning. The reason why I have chosen to spend my life doing astrophysics is because I want to understand how the universe works fundamentally. I want to understand how this universe we live in got to the point where it is today and what's going to happen to it in the future. And astrophysics is as much basic research as is possible. And at its heart, basic research is not possible if you ask, what is the economic gain by doing this? Instead, you have to ask, what is it something that we don't know, and what can we possibly learn in this field? A couple of examples of something that we wouldn't have discovered without basic research is quantum mechanics and radio waves. And without radio waves, we wouldn't have had any computers. Without quantum mechanics, we wouldn't have had any computers. And without radio waves, we wouldn't have had any cell phones or instant global communication. So to get back to that original question on how astrophysics can make our milk cheaper, the truthful answer is this. I have no idea. I have absolutely no idea. It might be that what we discover could cause a new technological revolution, something that we can't possibly predict today, or it might be that it is good for absolutely nothing, except, of course, understanding the entire universe. Thank you.